Hi everyone, today we are solving the lead code problem flip square submatrix vertically. Although it's an easy problem, most people solve this problem the slow way. But there is a smarter trick that makes it clean and fast. So we are given an m by n integer matrix grid and three integers x, y, and k. The integers x and y represent the row and column indices of the top left corner of the square submatrix, and the integer k represent the size of the square submatrix. Our task is to flip the submatrix by reversing the order of its rows vertically. So again, we are given a 2D grid and a square submatrix defined by positions x and y and the size k. Our task is simple. We need to flip this square vertically. That means the top row of the submatrix becomes the bottom row of the output matrix. And the bottom row became the top row. The bottom row became the top row. The most obvious solution here is we create a copy of the original grid and then rewrite the submatrix, the one colored here, in the reversed order. And yes, this works, but it uses extra space, which we don't actually need. So here is the key idea. Instead of copying, just swap rows directly inside the submatrix. So we don't need an extra matrix. Think of this like reversing an array. First, swap with last, and second, swap with second last. So here we loop through half of the rows from above, and for each row I, like this one, we swap it with row k minus 1 minus I. And for every column inside the square, we swap the element directly. So let's see this in the code. So we will loop through half of the row. So for I equals 0 and I is less than k over 2 and plus plus I, and then inside it another loop over all the key columns. So for j equal 0 and j is less than k plus plus j, we just need to swap each row with the corresponding or the mirroring row, like we will swap grid of x plus I and y plus j. This is the first element in the first row when I and j equal 0 and 0 with grid of x plus k minus 1 minus I and y plus j. So let's break down this swap line because this is the most important part. So we start from, as we said, x and y, which is the top left corner of the square. Now we move I, now I moves us inside the square, moves us down inside the square. So the I here moves us down inside the square, and j move us to the right. So the grid of x plus I and y plus j give us the current element of the top half of the submatrix. And now here is the trick. To find the matching element at the bottom, we use x plus k minus 1 minus I. Why? Because x plus k minus 1 till this part, this is the last row of the square because it's a zero indexed submatrix or zero indexed matrix. And we subtract I, or by subtracting I, this moves us upwards and this gives us the matching row. So we are basically pairing top row with the bottom row. So let's run it to make sure it runs correctly. Yes, I forget to define the J. Oops. Oh, my bad. I forgot to text. And here we go. Let's submit it. And for time complexity, it's still O of k squared. And this is because the outer loop here is processing the pairs of row, and each pair of row requires swapping k element. But the space complexity now is O of 1. It's constant because we are not copying to a new matrix. We are copying inside the same matrix. And that is how it turns that basic solution, we can turn basic solution into an optimized one. If you like the tricks like this, please follow the channel and like and subscribe. And thanks for watching. Happy coding and see you next video.